What's in a name? The answer to this question may vary greatly from case to case. Sometimes the name selected for a plant or animal fits it perfectly. Sometimes the name is a wonderful and concise descriptor of some vital aspect of the creature in question. Other times this is decidedly not the case. On at least a few occasions, the name is dreadfully, almost comically mismatched. Still, such misnomers do afford a chance for at least some amusement for those who are fond of life's little absurdities. One of the more glaring examples is a rather peculiar variety of plant. Spanish moss is a plant often associated with cinematic depictions of various swamps and bayous, particularly in the more gothic or romantic genres. It grows in dense tangles, most often found hanging from the branches of larger, older trees. This plant is an epiphyte, much like many species of moss. However, it is not a moss itself. It has more in common with pineapples, being in the same plant family, sometimes known collectively as bromeliads. It is also not native to Spain or anywhere nearby. Instead, it is found in the warmer, wetter regions of the New World, ranging from the southeastern United States down through the more humid parts of Central and South America. So yes, Spanish moss is in fact neither Spanish nor moss. That is only the beginning of the oddity, though. To be fair, Spanish moss is also known by a number of other names, generally a bit on the whimsical side. Such names include Old Man's Whiskers, Grandpa's Beard, and the somewhat unsettling Tree Hair. Alas, as whiskers, beards, and hair are decidedly animal structures, these names fall even further from the actual nature of the plant in question. The scientific name of Spanish moss is Tillandz usneoides. The species name usneoides essentially means resembling usnea. Usnea is the name of a genus of pale gray-green lichens found in places like the Pacific Northwest. The untidy tangles of epiphytic growth do superficially resemble Spanish moss. Still, one might ask where usnea got its name. The most likely answer is a modification of the Arabic word ushna, which can be interpreted to mean moss or lichen. So, in terms of the species name, Spanish moss is either named after a variety of lichen, or it is named after a more general term for lichen or moss. While Spanish moss is not at all closely related to actual moss, it is an even more distant relative to the lichens. Lichens are a specialized form of fungal growth after all, and fungus as a whole is more closely related to animals than it is to plants. The rest of the scientific name has a little more history to it. The genus Tillandsia is named for Elias Tillandz, a Swedish doctor and botanist who lived in the mid to late 1600s. Carl Linnaeus, who lived in the 1700s, gave the genus its name in honor of this predecessor. Those with a passing familiarity with biology will recognize Linnaeus as the father of modern taxonomy. He's the fellow who pretty well formalized the procedure of calling every distinctive form of life by a scientific name consisting of its genus name and its species name. Now, one might rightly ask why this genus in particular was named after this particular fellow. There is something of a story behind this, though it should be taken with a rather large grain of salt. The story goes more or less as follows. Tillandz was a professor in the Academy of Turku. Turku is a city in Finland, incidentally. At one point, when he was just a student there, he took a trip from Turku to Stockholm, just across the water in Sweden. A short distance by sea, but it was apparently a remarkably miserable trip. The seasickness was so bad that when it was time to return, he took a decidedly different route. Rather than brave the nautical nausea and maritime misery for a second time, this fellow walked around the Gulf of Bothnia, which divides most of Finland and Sweden. The ocean voyage would have been a fairly short trip, but the long walk around was close to 1,000 kilometers. Thus, one could reasonably say that Professor Tillandz was not especially fond of the water. By some accounts at least, Linnaeus was informed that the group of plants that would one day be known by the genus Tillandsia were found in relatively dry climates. Thus, it seemed appropriate enough to name them after a botanist of some note with a famous dislike for travel on the water. Alas, as it turns out, the opposite is true for Spanish moss at the very least. This species is almost entirely restricted to environments with relatively high humidity. Thus, if this little story is at all accurate, it is yet another bit of mismatched naming for Spanish moss and quite a few of its immediate relatives. Speaking of the genus Tillandsia, the bromeliads within this group are often referred to as air plants. This is a large genus consisting of several hundred different species. The vast majority of these species live as epiphytes growing on larger plants. Most do not even have functioning root systems. They do not parasitize these host plants. Instead, they derive their required nutrition from other sources. Some might well guess that as so-called air plants, these epiphytes derive their nutrients from thin air. Actually, thick air might be more accurate. The air plants have a number of tiny, specialized hairs coating their leaves. These hairs give the plants a pale, slightly fuzzy appearance. Their function is to absorb water from the atmosphere when there is sufficient humidity. This, combined with adequate rainfall, meets the moisture requirements for these plants. As for mineral needs, they get by with airborne dust and whatever minerals leach out of the leaves and bark of their host plants whenever it rains. It is something of a rarefied existence, but the generous adornments of Spanish moss on many of the larger trees throughout the South plainly demonstrate the success of this particular way of life. While such success is connected to their ability to absorb water from rainfall and humid air, these plants are also able to conserve water using an interesting little metabolic trick. Normally, a plant has to take in carbon dioxide and expel oxygen as it photosynthesizes. These gases mainly travel through stomata, microscopic openings on the plant leaves. While these stomata are open, the plant tends to lose water pretty quickly. If they are closed, it becomes a lot more difficult to obtain the necessary carbon dioxide for photosynthesis. This presents something of a problem if the plant needs to conserve water and yet continue photosynthesizing. In Spanish moss and many other plant species, the stomata are only open at night when the temperature is relatively low. The plant inhales carbon dioxide all night long and chemically binds it up in the form of organic acids. These get stored away in vacuoles within the cells. When morning comes, the stomata close and the carbon dioxide supply is essentially cut off. Throughout the day, the plant slowly releases the stored acids and turns them back into carbon dioxide and feeds this dissolved gas into the normal photosynthetic pathway. This fun bit of biochemistry was first properly described in plants within the genus Crassula. Because of this, and because of the organic acids used for carbon dioxide storage, it is commonly known as crassulacean acid metabolism, or CAM for short. It is an elegant system that allows the strange tangles of bromeliad life to minimize water loss as they photosynthesize through the daylight hours. Of course, the success of Spanish moss is not merely confined to the plant itself. There are a fair number of creatures that make use of this tangled plant in various ways. Birds often use it in their nest construction. Some go so far as to nest within the Spanish moss itself. A few bat species roost in the larger Spanish moss clumps. The jumping spider, Pellegrina tillandsiae, more or less lives exclusively on Spanish moss. There are quite a few small arthropods that inhabit this epiphyte, and this has given Spanish moss something of a reputation in certain circles. There is a group of particularly unpleasant mites in the genus Trombicula. More commonly, they are known as chiggers or red bugs. They are notorious for delivering remarkably itchy bites to the unwary, and there are those that claim the Spanish moss is infested with them. This is at least partially true. While it is unlikely to encounter these particular mites in the Spanish moss hanging from trees, they can often be found in clumps that have fallen to the ground below. So it is generally a good policy to avoid touching these fallen bits of Spanish moss at the very least. Basically, if you should happen to find any Spanish moss on the ground, it is best that you leave it well alone. Despite this potential danger, Spanish moss has found a number of uses in human endeavors. It is sometimes grown as an ornamental plant, though sometimes it's used as mulch instead. It also finds its way into various arts and crafts. I've seen it used as a form of decoration on a few unexpected occasions. It's also been used as packing material and as a stuffing for mattresses and upholstery. A more unexpected use is seen in the deserts of the American Southwest. While Spanish moss does not grow in such dry climates, it can be brought in as a component of a type of evaporative cooler. Because of the native home of the Spanish moss, these particular devices are sometimes known as swamp coolers. The mechanism works roughly as follows. A small amount of water is steadily sprayed onto a clump of Spanish moss inside the cooler, and a fan is used to move air across this clump. The material is perfect for spreading water out over a large collective surface area, allowing for highly effective evaporation. This evaporation cools the air as it passes through. As this method is used in dry climates, the added humidity is not particularly unpleasant or inconvenient. While it is not quite as sophisticated as proper air conditioning, it is a good deal less expensive. As I've said before, Spanish moss is not actually moss. As it is a type of bromeliad, it is a flowering plant. One might ask just where the flowers are exactly. The answer is pretty well out in the open. They just tend to be easily overlooked. While several of its relatives are pollinated by various creatures, Spanish moss is wind-pollinated. As such, the flowers are relatively small and inconspicuous. They eventually mature into small, narrow seed capsules. When these dry out and open, the distinctly fluffy seeds are caught on the wind. At least some end up drifting over to nearby tree branches to grow into another generation of tangled hanging epiphytes. Still, it is not uncommon for Spanish moss to propagate itself in a more direct fashion. Various fragments may be carried off by birds or other animals, or even caught up in the wind during storms. So long as they get tangled up in suitable tree branches, these fragments can begin a new colony of Spanish moss wherever they have landed. In the end, this strange little plant has done remarkably well for itself, flourishing in warm, humid climates throughout the New World. It has proven to be adaptable and tenacious, capable of thriving while simply hanging from tree branches. Beyond this, it has become quite useful in human endeavors and as a part of its native ecosystems. Under other circumstances, one might easily say that such a successful species lives up to its name. Given the peculiarities of this case, I would suggest that this plant far exceeds its mismatched nomenclature. Still, I suppose even this misnomer might just add to the distinctive charm of this most unusual epiphyte. Thank you for listening. I hope you have enjoyed this brief glimpse into the more unusual side of the natural world. If you wish to know more, here are a few things that might be worth looking into. If you found this enjoyable, feel free to leave a like. If you think others would enjoy this content, by all means, share. If you have something to say or ask about, honest comments are always welcome. If you wish to see more from this channel, a subscription would be most helpful. Until next time.